Yo, what is going on? It is Wednesday, April 27th, 2022. April is winding down like a fastball pitcher's pitch. I don't know, that was a random analogy. But you're not here for the random analogies. You're at welcome to Coding with Shaf, and thanks for watching my video. Please like and subscribe and comment in the link below. Yeah, and just let me know how I'm doing. Okay, so yeah, I'm here today to do Leetcode problem 1356, sort integers by the number of 1 bits. Okay, cool. So this should actually be a pretty easy problem. The only thing is that I'm gonna be doing this in Java, and I'll let you know in a second what the issue with that is. But well, you know, it's one of the complaints about why people don't like Java and like other languages that don't have constraints, certain constraints that Java has. But anyway, let's get to it. You're given an integer array R, like the pirates, or to sort the integer in the array in this ascending order by the number of ones in their binary representation, and in case of 2 or more integers have the same number of ones, you have to sort them in ascending order. Return the array after sorting it. Okay, so basically you sort the number of array, you sort these numbers based on their 1 bits. Okay, so the number of ones. So basically should be easy. Each element, this is the decimal representation of each element, so I'm gonna convert it to the ones representation. Right, so you have 1, then you have, this is just basically binary arithmetic, then you have 3, oh sorry, you have 3, you have 4, that would be 100, 5, and in case you don't know how to do this conversion, go back to school. No, I'm kidding. This is pretty easy, right? And 7 equals 101, I believe. Let's see. This is 7 is 111, and 8 is 100. Okay, so basically you have to sort this like this. Okay, 0, 1. So this 1 and 2 have 1 bit, right? Just take a look at the answer here. 1 and 2 have 1 bit. 3 has 2 bits. 4 has 1 bit. 5, 6, 7, 8 has 1 bit. So the numbers, if these all have 1 bit, a 0 comes first because 0 has 0 bits, right? 1 has 1 bit. We'll group them together. 1 has 1 bit. 2 has 1 bit, and 8 has 4 has 1 bit, and 8 has 1 bit. So that's pretty much the ordering of the first numbers. Then the next numbers have bits 2. So 3 has 2 bits, 4 has 2 bits, 3 has 2 bits, 5 has 2 bits, and 6 has 2 bits. So the numbers are 3, 5, and 6. And then finally 7 has the most bits. 7 has more bits than 8. Just don't get confused with that. And this is your final ordering. Okay, so algorithmically, how do we do this? Okay, so since I'm doing this in Java, I'm gonna have to do something. Normally you would do something if I'd want to sort using the inbuilt sorting function, I'd do something like this, right? And that would just sort the numbers. But since I have a custom criteria, which I have to sort via using a comparator, you'll see what I mean in a minute. And you know how to write a comparator. Now, if someone knows a way around this using a more modern Java nicety, that would be great. Or another nicer, I have a way around it, but another way around it that involves using the custom comparator on the array sort function, that would be great. And there probably is, so forgive me if I'm not up to speed on that. So I'm going to write my custom comparator. And what is my custom comparator doing? My custom comparator is just comparing the number of ones on each, and if remember, the comparator returns -1 and +1, right? If the vowel is not equal to 0, return vowel. That means if it's when it's equal to 0, that means the two things are equal, have an equal number of ones. If they don't have an equal number of ones, then you just return a minus b, which is basically saying return the number of ones that has return whichever has the larger number of whichever is in sorted order from smallest to largest, the smallest and larger one. Okay, that's what that's saying. So, and then at that point, all I'd have to do is return r, right? You would think that's it, and of course you need to write your ones function. So int ones, int num, and int total equals 0, while num greater than 0, total plus equals. So this is called a bit shift operator. This is basically using bit shift, and for those who are not familiar, this is the bit shift operator below. This is saying shift the bits to the right, turn total, shift the bits to the right one by one. So if I have 11011, right, then this becomes 1101, and you could put a 0 here. If you want, it's not necessary. Then this becomes 00110. Then this becomes 0001 1, and then this becomes 00001, and then 0 finally. Okay, so basically I'm taking off this bit here on each iteration, right? Because I'm moving these bits to the right, okay? And whatever these bits happen to be, okay, I'm just being like, oh, okay, well, this is the bit that I'm going to take, okay? Right, let's just make sure this is right. Yes. Okay, sometimes you can get a little squirrely, and then this becomes 1 1, 0 1, and so on. Okay, and then all the way down to 0. So, and I'm just counting that and summing it whenever it's true. And how do I determine it's true? I do an and of this first bit with 1, because an and 1 and 1 is equal to 1. 1 and 0 is equal to 0. 0 and 1 is equal to 0, so it will extract the number of ones. Okay, so now if I was to run this, you'll see what I mean. Okay, not int, if. You probably were distracted by that the whole time. So see, there's no custom comparator for this. Okay, so in the interest of brevity, I'm going to keep this comparator, but I'm going to do something else here. Priority queue. Priority queue is basically another way of sorting, but there's extra space involved. Now, if I used another language, I wouldn't need to do this, okay? But let's just say for now I'm going to use Java, okay? So I replace my priority queue. Now, in I equals 0, I have to put the elements of my array into my priority queue. ar.length, I++, q.add arri, and then, so now everything's added to my priority queue, and this, if in case you're wondering, is O n log n order. The same with arrays, just sorting the arrays. So they're both O n log n operations. Okay, so I'm adding elements to my array, int I equals 0, while not PQ is empty. ARRI equals PQ dot poll. Let's see. Cannot infer arguments for priority queue. We don't need this ARR here. That would be nice, but we don't need to do that. And let's just make sure. Cannot find symbol. This should be num. And there you go, accepted. And there you go. Okay. And it's slow because part of the reason, well, is because, you can never really tell, right? The same code submitted twice, but it's also because this bit shifting is O of n of the number of bits, right? And its complete operation is completely dominated n log n, but this is n log, and if this is this log n bits, I guess log n operations or log b operations, you can almost think of this as O of n log b, right? Because this one's operation is occurring inside this comparison. Okay, so yeah, that's it. If you like this video, like, subscribe, and do all that good stuff. Thanks for watching, and I'll see you around. Oh, by the way, the discussion for this video, I posted it as usual on Leetcode, so discussions for this problem, you can check it out, and yeah, thanks.